Again, we're on page 26 for today. I want to take a look at a couple of the problems that you saw in your video for homework last night, those notes over those first two strategies for factoring. I want to take a look at something with those before we move on to our practice problems for today. Right? So here are your notes from page 26. Right? This should look familiar because this is what you saw in the video because I did last time's video. When you looked at this grouping idea, you were basically continuing on with that idea of a GCF, right? What's the greatest common factor for this portion of my polynomial and for this portion of my polynomial, okay? So when we have four terms, we use grouping, and that's the big idea behind grouping, right? It's pulling out greatest common factors every time. What we did not do here was state the x-intercepts. So I wanted to go back and do that really quickly as part of our notes for today. So for x-intercepts, if I've got, like the second example here, something like x minus 3. This is something we're familiar with finding those x-intercepts from. So my x-intercept I would expect from here would be positive 3. But something like this guy, right, an x squared, we haven't seen before when we talked about x-intercepts in factored form. For right now, if you still have an x squared, what we can do is set that thing equal to 0 and sort of treat this like I'm going to solve a square root. But if you notice, when I move that 1 to the other side by subtracting, I now would be taking the square root of a negative number, okay, which we can't, for right now, can't do. We haven't talked about that yet. So for this guy, I'm going to leave that alone for right now. Okay. Same with that example down here. I'm going to leave that alone. If I have x squared still, for right now, we're going to leave that alone. Okay. But this x plus 4, we know we would get an x-intercept of negative 4. Up here, I don't have x squareds. Okay, I have plain old x's, but these again look a little different than what I've seen before. I'm only used to having x plus something or x minus something. So I want to talk about how to get an x-intercept out of a factor like this. And I believe somebody asked me a question about a problem like this maybe last week. If they were working on some practice with writing function forms based on x-intercepts. So if I take a look at my first factor here, to find my x-intercept, since I have 2x instead of just x, I'm going to set that guy equal to 0 and then get x by itself. So my first step here would be to subtract 1. That would leave me with 2x equals negative 1. And then I'm going to divide by 2. So I would get x to be negative 1/2 as an x-intercept. And then I'm going to do the same thing for this other factor. I'm going to take this guy, 3x plus 2, and set it equal to 0, and then get x by itself. We could also think about this x minus 3 the same way. Set it equal to 0 and get x by itself gives me my x-intercept. Okay. So here, since I've got something in front of the x, I've got to kind of take that longer way to get my x-intercept. So I'm going to move that 2 over. I get 3x equals negative 2. And then divide both sides by 3. So x would be negative 2/3. I'm going to take a look at these for those other problems that you looked at factoring with the trinomials, with the 3 terms, where you use that AC method. Since the video was already kind of long, I thought we could go over that x-intercept part together. Okay. Any questions for me so far? Okay. So I'm going to take a look at the next page, page 27. Same idea. Again, this should look familiar from your notes. So the last thing we're going to look at is finding those x-intercepts. So if I take a look at my first example here, x minus 2 is going to give me an x-intercept of positive 2. And then x plus 5 would give me an x-intercept of negative 5. For my next problem, x plus 3 means I have an x-intercept at negative 3. And then this 2x plus 1, since I have that 2 in front, I'm going to go ahead and set this equal to 0 and solve for x. That means I need to start by subtracting 1 from each side. So then I would have 2x equals -1, and then divide both sides by 2 to get x equals -1/2. Just tack that onto my list here. For the next example we've got, both of these still have x squareds, so I'm going to leave them for now. Again, later on, and I said this in the video, later on we'll take a look at how to keep factoring something that's only 2 terms. Right? That'll be homework for tonight, actually, a video on factoring stuff when it's only 2 terms. But for right now, since we don't know how to handle that kind of stuff, we're going to leave it alone. As we learn how to factor stuff that has 2 terms, then we can go back and fill in those x-intercepts. Okay? And then for our last problem here, I just want you guys to give this one a shot. So tell me what x-intercepts I would have from those 2 factors. Okay, so I'll give you guys just a minute to work on that. For that first factor, again, I'm going to want to set that equal to 0 and solve for x. So add 2 to both sides. It gives me 3x equals 2. And then divide both sides by 3 to get x by itself. So we would have an x-intercept at 2/3. And then our other x-intercept, again, you can approach that the same way. Set x minus 5 equal to 0. Add 5 to both sides to get x by itself. And you would get x to be 5. But since this format is one that we've seen and worked with before, most of us should be pretty comfortable saying that our x-intercept would be 5 out of that factor. Questions for me? Okay, so let's take a look at some practice problems. I'm going to go to page 30 in your packet. Page 30 has the practice set for this lesson. So on page 30, we're going to pick out the problems that we know how to factor right now. So that would be anything with 4 terms or 3 terms. So on page 30, I'm going to first just pick out the problems that we know how to factor. So I could factor number 1, number 2, number 4, number 6, number 9, and number 10. Those are problems that we know how to factor right now because they have either 3 or 4 terms. So if I take a look at what's happening here on number 1, I've got 3 terms. That means I want to use AC method. Okay, so AC method means I'm going to start by identifying that lead coefficient and the constant term, and I'm going to multiply them together. So 3 times, be careful of your signs here, -5 would give me -15. And now I want factors of -15 that add to -2. Some of you will recognize the factors that you need right off the bat, like it's already on the page in front of you. That's how quickly that you'll see what factors you need. For some of you, it's going to be maybe a little bit of a challenge to identify those factors. Whatever like version of that spectrum you're on is fine. For a lot of people, maybe those smaller numbers are easy. When we get to some larger numbers, it gets to be a little more difficult. Wherever you're at on that continuum is fine. What I'll tell you, the same thing that I told you in the video, is that if you are stuck, I want you to make a list. Start with 1 times what? 2 times what? 3 times what? Okay. This is an odd number, so I know 2 isn't going to be a factor, so I would skip 2 and go to 3. Okay. But write your factor list, okay, and then find the ones that you need from that list. So that's what I'm going to do here. So this could be -1 times 15, or 1 times 15, or not 2, -3 times 5, or 3 times -5. There's the one that I need. Those would add to -2, right? 3 times -5 gives me -15. 3 plus -5 would give me -2. So those are the factor pairs that I want. So what I'm going to do is I'm actually going to grab a scratch paper here. The space is kind of tight to work in with my big giant marker. What I'm going to do is rewrite this middle term using the factors that I've chosen. So that first term stays the same, 3x squared plus 3x minus 5x minus 5. So I rewrote that -2x by splitting it up using the factors that I chose. Now, remember, this doesn't change the problem because if I were to combine my like terms, I would get back to -2x. So it's not a different problem. It's the same problem, just like wearing a different hat, okay? The reason that I want to do this is so that now I can factor this by grouping, right? That's the big idea. Factoring by grouping goes back to just pulling out GCFs from things. And that's what we talked about last time when we met, right? I looked at what's the greatest common factor here and how to divide that out. So when we talked about factoring something with 4 terms, factoring by grouping, we said, hey, let's split this up into something we already know how to do. There's not a GCF for the whole problem, so let's break it up and look for GCFs for those smaller pieces because I know how to do that. And with factoring our 3-term problems, factoring our trinomials, again, the strategy here is to take this problem that I don't know how to approach right now and rewrite it, manipulate it so that it looks like something I do know how to work with. That's like the biggest idea in all of mathematics, is to take a complex problem and figure out how I can approach it with the strategies that I already know, okay? So I took this 3-term thing and I rewrote it so it's got 4 pieces because I know how to handle something with 4 pieces. That's what we're going to do here, okay? That's the idea behind the AC method. So now that I've split my problem up into groups, right? First 2 terms, last 2 terms, I'm going to look for the GCFs for each of those pieces. So for my first group, I see I've got 3's and I've got x's as part of both of these terms. So I'm going to pull out a GCF of 3x. So I'm going to write that in front. And then in parentheses, I'm going to write what's left over when I factor that out, divide that out of each term. So 3 divided by 3 would just give me 1. X squared divided by x would give me x. Plus, I'm just going to treat this as one whole big piece. 3x divided by 3x. Remember, anything divided by itself is just 1. For my second group here, -5x minus 5. Remember, I said in that video, pretty much every time that we see our second group start with a negative, I'm probably going to factor a negative something out as part of my GCF. Here, I've got 5 and 5, so I'm going to factor out -5. -5x divided by -5 would be a -5 divided by -5 is a positive 1x. And then -5 divided by -5 would be positive 1. Remember, anytime that I factor by grouping, that stuff in parentheses should match. If it doesn't, I need to go back and double check my work, okay? Something else to look at if you started with a C method is to go back and double check your factors, okay? So if you did the GCF part of it right, but these parts don't match, that probably means that you picked the wrong factors and you need to go back and double check your work. Since we have matches here, that means that I now treat this thing in parentheses like my GCF. Remember back in that notes video, I went ahead and just like scribbled it out because I said, I don't care what it is, I just care that it's the same, because if it's the same, that makes it a common factor for each of those terms. So this x plus 1 is my common factor now, so I'm going to pull that out. Once I factor that out, I'm going to write what's left over. And in the video, I just sort of covered that piece up with my fingers so that we could see what was left over a little bit easier. That's a strategy that I like to use, and I found that it's helpful for a lot of people when you have kind of a hard time seeing what that leftover part is. If I factor it out from that first piece, I'm left with 3x. If I factor it out from the second piece, I'm left with minus 5. Okay, so this would be my factored form for number 1, x plus 1 times 3x minus 5. And then the other piece we want to do is figure out what those x-intercepts are. And you actually have a bank of options for your x-intercepts. Okay, so if you get x-intercepts that aren't listed down here, go back and double check your work. For this problem, I would get x equals -1 as an x-intercept. And for this guy, I'm going to go ahead and set this equal to 0 and get x by itself. So I'd have to start by adding 5 to both sides. 3x equals 5, divide by 3, and I get x equals 5/3. So my x-intercepts would be -1 and 5/3 for number 1. And if I go check that list at the bottom, I've got -1 and I've got 5/3 down here. I'm okay. Questions on number 1? Let's take a look at number 2. Number 2 has 4 terms, so that's a problem that we can handle. Again, I'm going to work on my sort of scratch paper here. If you need to work on scratch paper instead of the space in your packet, that's fine too. So we've got 4 terms, so I'm going to use grouping. Okay, so I have 5x cubed. I'm just recopying the problem again, so I have a little more space to work. And we split up into our groups, first 2 terms and last 2 terms, and we're going to look for the GCF, that greatest common factor, for each group. For my first group, I can see that I can divide my coefficients by 5, and then I also have x's as each part. Remember, we want to factor out whatever that smallest exponent is for the x. So I'm actually going to take out a 5x squared. Then I'm going to write what's left over. 5 divided by 5 would be 1. X cubed divided by x squared would be x. Minus -10 divided by 5 would be -2. Okay, so -2 there. And then x squared divided by x squared would be 1. No more x's. So I would just have x minus 2 in parentheses there. For my second group, 3x minus 6. 3 and 6 have a greatest common factor of 3. So I'm going to factor out a +3. 3x divided by 3 would just be x, or 1x. And then -6 divided by 3 would be -2. Remember to be really careful with your signs here. A lot of the errors that I see are just sign errors. You forgot to write that this was +3, or that you factored out a -5, or that it was -2 left over. So just watch your signs. From here, I can see my stuff in parentheses is the same. So I get to pull that out now as my new greatest common factor for this problem, right? I can sort of think of this as like a big group, right? We split up into groups and look for GCFs. Now here's my new kind of bigger, clunkier group. And we're just looking for the GCF, which is that stuff in parentheses, since that's what's the same. And then left over would be 5x squared plus 3. So I'm going to jot my factors down here. X minus 2 times 5x squared plus 3. Remember that the order in which you list your factors is not important. So this, what I have here, would be the same as 5x squared plus 3 times x minus 2. As long as the factors themselves are the same, their order is not important. So as you're working through some of your problems, if you have maybe an answer key, or if you're looking up your homework with the document that's posted on the website on Google Classroom. If you see that you have this order on the answer key, but you wrote this, that means the same thing. It's like it doesn't matter what order in which I write my x-intercepts as long as I have the same ones. And then from here, to find our x-intercepts, remember, we don't know how to factor anything with an x or find the x-intercepts from that x squared stuff. And we don't know how to factor things with only 2 terms this minute. So we're going to leave this one alone for now and just pull out, that would be x equals 2 as our x-intercept for number 2. That's the one that we can identify right now. I want you guys to try number 4 and number 6. Number 4 has 3 terms, so we're going to use AC method for that. Okay. So I've got x squared plus 1x minus 90. For AC method, I need to identify that leading coefficient and the constant term. Now, I don't see a number in front of x squared. Remember that that means that that leading coefficient is 1. I'm going to want 1 and negative 90. And I'm going to multiply those together. 1 times negative 90 would give me negative 90. Again, be careful with your signs. Signs are important. And now I want factors of negative 90 that add to 1. Does anybody have those factors for me?
Negative 9 and 10.
Perfect. Negative 9 times 10. Okay. Multiply to negative 90, but if I added them, I would get positive 1. So now I'm going to rewrite my trinomial as something with 4 terms by splitting up that middle term using the factors that we've chosen. So x squared minus 9x plus 10x minus 90. And now that it's 4 terms, I'm going to factor by grouping. So here's my first group and my second group. And I'm going to look for the GCF for each group. What's the GCF for my first group here? X squared minus 9x. What factor do they share?
1x.
Perfect. And then what would I have left over, Taylor?
X minus 9.
Perfect. Now, somebody else, what's my GCF for this second group? What number could I use to divide 10x and negative 90?
10.
10, perfect. Positive 10. So that would give me x minus 9. Stuff in parentheses is the same. So now I can pull that out as my GCF. And that would leave me with x plus 10. So my factored form would be x minus 9 times x plus 10. And my x-intercepts would be 9 and negative 10. Questions for me on number 4? Okay, let's take a look at number 6, grouping. So I'm just, again, going to recopy my problem, x cubed minus x squared plus 2x minus 2. Since I've got 4 terms, I'm going to split this up into groups. GCF for my first group. What's the greatest common factor for those terms?
X squared.
And what's left over when I factor out x squared?
X minus 1.
Perfect. How about for my second group? What's my GCF there? Two x minus 2. What do they have in common?
Factor of 2.
And then what would be left over when I factor that out?
X minus 1.
Perfect. Again, your stuff in parentheses should always be the same when you're using this grouping strategy. So now I pull that x minus 1 out as my GCF, and left over would be x squared plus 2. So my factored form is x minus 1 times x squared plus 2. And then to find our x-intercepts, I know from this x minus 1, I would have an x-intercept of positive 1. But for the x squared guy, we're going to leave that for now. The last couple we have on this page are number 9 and number 10. Number 9 is another trinomial, so we're going to use AC method on that. And then number 10, also a trinomial, so AC method for these last two. Number 9, 4x squared minus 4x plus 1. What I neglected to say as we started these problems is remember that we always want to start by looking to see if my terms at the very start of the problem have a GCF. There's a common factor I can pull out right away. For everything that we've looked at so far, including this guy, there's no GCF for me to pull out right away, but that is always the first thing you want to look for as you're factoring. No GCF here, 3 terms, so I'm going to use AC method. I need my leading coefficient and my constant term. I'm going to multiply them together. So that would be 4 times 1 gives me 4. And I want factors of 4 that add to negative 4. Since I want a negative out of here, and I've got a positive right now, that's a pretty good hint that I'm going to want to use negative times negative. Okay? So negative 1 times negative 4, or negative 2 times negative 2. I would also have positive 1 times positive 4, and positive 2 times positive 2, but none of those are going to add to a negative number. So I'm going to go ahead and skip over those. Okay. What I want would be these negative 2's. So I'm going to rewrite my polynomial with that middle term split up into negative 2x and negative 2x. So I've got 4x squared minus 2x minus 2x plus 1. Now that I have 4 terms, we go back to grouping. First 2 terms are a group, and the last 2 terms are a group. The GCF for my first group, 4 and 2, are both divisible by 2, and then x squared and x are both divisible by x. So my GCF for the first group would be 2x. Now I'm going to write what's left over when I factor that 2x out. So 4x squared divided by 2x would leave me with 2x. 2x divided by, or sorry, negative 2x divided by 2x would be negative 1. And then for my second group here, I don't really have an interesting GCF, right? Negative 2 and 1 don't have any common factors other than 1. This first term is the only thing that has an x as part of it. So as I went over in the notes, when you don't have what we would call an interesting GCF, you're just going to end up pulling out a 1. It is still important to factor out that 1, but we don't have anything like really exciting that we're going to be able to pull out of there. Now I will point out though, since this group starts with a negative, that tells me that I probably want to factor out negative 1. Let's say I didn't factor out negative 1 and I just factored out a positive 1. In parentheses, I would have negative 2x plus 1. That is not the same as what I have in parentheses from my first group. Everything's off by a sign, okay? So this is what I meant when I said if your stuff in parentheses doesn't match, go back and double check your work. So I need to factor out negative 1 here so that these signs change. And I've got 2x minus 1 in parentheses. And now that stuff matches. So from here, 2x minus 1 is the same for both of those. So I pull that out as my GCF. And then left over, I have 2x minus 1. I have the same factor twice. We talked about this, I think it was last week when we looked at x-intercepts. If I had that same thing listed twice, you could also write this as 2x minus 1 squared. And since we talked about multiplicity, what those exponents mean, this tells me some information about what I would expect at the x-intercept for this graph. I would expect that quadratic behavior, right? So I'm going to have an x-intercept at, let's see, 2x minus 1 equals 0. If I find that x-intercept, I want to add 1 to both sides. So I have 2x equals 1. Divide both sides by 2, and I get x to be 1/2. You don't need to do the same thing for the other factor. It's identical, so it's also going to give you 1/2. What this tells me then is if I looked at the graph of this thing, I would have that quadratic behavior at my x-intercept at 1/2. That's what my graph's going to look like, right? All this stuff ties together. Okay, so number 9, we got 2x minus 1 squared. If you wrote it separately, that's fine too. It means the same thing. And our x-intercept would be 1/2. Our last example on this page, number 10, is x to the 4th minus x squared minus 12. Since I've got 3 terms, we're going to use AC method here. My lead coefficient is 1, so that'd be 1 times negative 12. That gives me negative 12. Factors of negative 12 that add to negative 1. If you don't see them right away, make a list. Negative 1 times 12, or 1 times negative 12, negative 2 times 6, or 2 times negative 6, negative 3 times 4, or 3 times negative 4. That one will work, 3 times negative 4. So I would have x to the 4th plus 3x squared minus 4x squared minus 12. Now that I've rewritten this as 4 terms, I'm going to use grouping. So first group, second group. I want you guys to take a minute and look for those GCFs for each group and write what's left over. For my first group, my GCF would be x squared. That leaves me with x squared plus 3. For my second group, my GCF would be negative 4, which would leave me with x squared plus 3. My stuff in parentheses is the same, so now I get to pull that out as my GCF, x squared plus 3. And left over, I have x squared minus 4. Again, your homework tonight, that video that you're going to watch, is going to show you how to be able to handle stuff that only has 2 terms, how to factor stuff that looks like this. Since we don't know that right now, we're going to go ahead and stop on this problem. Okay, and we'll come back to that one next time. So my factored form as of right now is x squared plus 3 and x squared minus 4. From here, I can't see my x-intercepts because we still have those x squareds. So again, we're going to stop on that problem and we'll come back and look at that one next time to see how I can continue to factor this to be able to find those x-intercepts. Okay, a couple of things. One, I have a handful of people that still need to turn in their little like graphing quiz, their Google Doc. So if you are one of those people, please do that sooner rather than later. I want to be able to give you guys feedback on how you're doing so that I can see if we need to touch base on the end behavior or the x-intercepts or the x-intercept behavior stuff before we continue to build and use all of the factoring stuff that we're working on now and that material together. So if you're shaky on that stuff, it's going to make what we do moving forward even harder. So please make sure you get those turned into me. For the rest of class, I'm going to work through some more example problems. For anybody that wants to go through some more examples with me, everybody has a Delta Math assignment posted for them in Delta Math. So if you'd like, you can go work on your Delta Math assignment now. Pop back in with questions as you have them. For anybody that wants to stick around and go through some more examples together, I'm going to go through some problems that we could factor from page 31. Okay, so I am going to stop sharing for a second and